Section 1, Weathering. This is Mr. Ruby, and we're going to talk about weathering today. Weathering and its effects. Can you believe that tiny moss plants and burrowing voles, shrew, and even oxygen in the air can affect solid rock? These things and many more weaken and break apart rock at the Earth's surface. Together, surface processes that work to break down rock are called weathering. Weathering breaks rock into smaller and smaller pieces, such as sand, silt, and clay. These small, loose pieces are called sediment. The terms sand, silt, and clay are used to describe specific sizes of sediment. Sediment then changes gradually into soil. The formation of soil depends upon the amount of weathering that occurs in a specific place. Over millions of years, weathering has changed Earth's surface. The process continues today. Weathering wears mountains down to hills, as shown in Figure 1. Rocks at the top of the mountain are broken down by weathering and helped carried downhill by gravity, water, and ice. Weathering also helps produce strange rock formations like those shown at the beginning of this chapter. Two different types of weathering, mechanical weathering and chemical weathering, work together to shape Earth's surface. Figure 1. Over long periods of time, weathering wears mountains down to rolling hills. Compare the Rocky Mountains to the Appalachian Mountains. The Rockies in the west are younger mountains. Here in the east, the Appalachian Mountains are much older and have more time to weather down. Let's start with mechanical weathering. Mechanical weathering occurs when rocks are broken apart by physical process. This means that the overall chemical makeup of the rock stays the same. Each fragment has characteristics similar to the original rock. Growing plants, ice are some of the things that can, not all of the things, but some of the things. These physical processes produce enough force to break rocks into small pieces. Reading check. What can cause mechanical weathering? According to our reading above, growing plants, growing animals, and expanding ice are some of the things that can mechanically weather rock. Plants and animals. Water and nutrients that collect in cracks of rock result in conditions in which plants can grow. As the roots grow, they enlarge the cracks. You've seen this kind of mechanical weathering if you've ever tripped on a crack in the sidewalk near a tree, as shown in Figure 2A. Let's scroll back up, look at this closely. Figure 2A, right here, there's the crack the tree has made in the sidewalk. Our skateboarder friend here perhaps tripped on that crack. Sometimes the roots will wedge rock apart, as shown in Figure 2B. Figure 2B shows a tree wedging in between rock crevices and breaking those rocks apart. Burrowing animals also cause mechanical weathering, as shown on this figure, Figure 3. As these animals burrow, they loosen sediment and push them to the surface. Once the sediments are brought to the surface, other weathering processes can act on them. So we have insects, birds, burrowing animals, lizards, all of these things that bring rock to the surface where more weathering can occur and act on them. Ice wedging. The mechanical weathering process known as ice wedging is illustrated in Figure 4. Ice wedging occurs in temperate and cold climates where water enters cracks in rocks and freezes. Because water expands when it turns to ice, pressure builds up in the cracks. This pressure can extend the cracks and break apart rock. The ice then melts, allowing more water to enter the crack, where it freezes and breaks the rock even more. Ice wedging is most notable in the mountains, where warm days and cold nights are common. It is one process that wears down mountain peaks. This cycle of freezing and thawing not only breaks up rock, but also can break apart roads and highways. When water enters cracks in road pavement and freezes, it forces the pavement apart. This causes potholes to form in roads, something we're very familiar with here in Maine. Surface area. Mechanical weathering by plants, animals, and ice wedging reduces rocks to smaller pieces. These small pieces have more surface area than the original rock body, as shown in Figure 5. As the amount of surface area increases, more rock is exposed to water and oxygen. This results in a different type of weathering, called chemical weathering. Chemical weathering. The second type of weathering, chemical weathering, occurs when chemical reactions dissolve the minerals in rock or change them into different minerals. This type of weathering changes the chemical composition of the rock, which can weaken the rock. Next, you'll see how chemical weathering happens. Natural acids. Naturally formed acids can weather rocks chemically. When water mixes with carbon dioxide gas in the air or soil, a weak acid called carbonic acid forms. This is the same weak acid that makes soft drinks fizzy, especially when shaken. Carbonic acid reacts with minerals such as calcite, which is the main mineral that makes up limestone. This reaction causes the calcite to dissolve. Over many thousands of years, carbonic acid has weathered so much limestone that caves, such as the one shown in Figure 6, have formed. Chemical weathering also occurs when naturally formed acid comes in contact with other rocks. Over long periods of time, the mineral feldspar, which is found in granite, some types of sandstone, and other rocks, is broken down into clay, mineral called kaolinite. Kaolinite clay is common in some soils. Clay is the end product of weathering. When you've broken a rock down so it can't get any smaller, what you're left with is particles so small it's called clay. Let's look at Figure 6. Caves form when acidic groundwater dissolves large amounts of limestone, causing carbonic acid. In this cave you see the stalactites and the stalagmites. Plant acids. Yes, plants excrete acid. Some roots and decaying plants give off acids that also can dissolve minerals in rock. When these minerals are dissolved, the rock is weakened. Eventually, the rock will break into small pieces. Do you know how a plant can benefit from being able to dissolve rock? Think about this. How could a plant benefit from breaking up rock? Where could a plant grow? Oxygen. Oxygen helps cause chemical weathering. You've seen rusty swing sets, nails, and cars. Rust is caused by oxidation. Oxidation occurs when metallic materials are exposed to oxygen and water over prolonged periods of time. For example, when minerals containing iron are exposed to water and the oxygen in the air, the iron in the mineral can form a new material that resembles rust. One common example of this type of weathering is the alteration of iron-bearing mineral magnetite to a rust-like material called limonite, as shown in Figure 7. What factors do you think would affect how fast minerals are oxidized? Let's look for Figure 7. Figure 7. Looking at the change with the oxidation. Effects of climate. Mechanical and chemical weathering occur everywhere. However, climate can affect the rate of weathering in different parts of the world. Climate is the pattern of weather that occurs in a particular area over many years. Let's repeat that. Climate is the pattern of weather that occurs in a particular area over many years. In cold climates where freezing and thawing are frequent, mechanical weathering rapidly breaks down the rocks through a process called ice wedging. Chemical weathering is more rapid in warm, wet climates. Thus, chemical weathering occurs quickly in tropical areas such as the Amazon River region of South America. Lack of moisture in deserts and low temperatures in polar regions slow down chemical weathering. Which type of weathering do you think is most rapid in the area where you live? Let's think about that. We're in Maine, we have winter, we have spring, we have many potholes. Which type of weathering would that be, where ice is affecting it? Wrapping this up, effects of rock type. Yes, depending on the rock, depends on the weathering. Rock type also can affect the rate of weathering in a particular climate, which is the climate is the period of weather over time. In wet climates, for example, marble weathers more rapidly than granite, as shown in Figure 8. This would be the marble over here. This is the marble. This is the granite. Now you can understand how weathering affects rocks, caves, mountains, and even buildings and streets. Weathering is an important part of the rock cycle. The rock cycle. When weathering breaks down rocks, it produces sediment that can form sedimentary rock. Weathering also begins the process of forming soil from rock and sediment. This is discussed in the next section. A few section assessment questions. What is the difference between mechanical and chemical weathering? You should be able to get that after this reading. Explain how tree roots can weather rock and how a prairie dog can weather rock. Are these chemical, mechanical, or both? What effect does carbonic acid have on limestone? And where could you find carbonic acid in your daily life? And how does climate affect the rate of chemical weathering? Well, that wraps up this reading of Section 1 of Chapter 2. This has been weathering. After you've read this, you should be able to describe the difference between mechanical and chemical weathering and explain the effects of climate on weathering. Here's your vocabulary: weathering, mechanical weathering, ice wedging, chemical weathering, oxidation, and climate. Thank you for listening. This has been Mr. Ruby. Have a pleasant evening.